Naming binary molecular compounds, folks. So in your notes where you left off, you're going to add this in there. So the chart at the top, naming binary molecular compounds. What we use for molecular. Now, a molecular compound, guys, is what? What does molecular mean? Covalent. So up until this point, we have only talked about ionic compounds, guys. Today, we're talking about covalent compounds, which again, the name is molecular. All right, molecular. These use prefixes to tell you how many atoms of each element you have. So in molecular or covalent compounds, guys, what do you have present? They're made up of what?
2 nonmetals.
2 nonmetals, and that's the key. 2 or more nonmetals. All right? So these compounds, the only time you will use prefixes to tell how many atoms you have is when you have a covalent compound. So the first step, guys, in any problem is to do what? What's that? Exactly. What Bella said, guys, you have to determine, is it ionic or covalent? All right, that's the first step. So what I want you guys to do is to make a chart in your notebook with all these prefixes. Names, guys, the numbers, and then the prefix corresponds to the number that's there. No? Tetris? You've never played Tetris? It's a classic. Yeah.
Oh,
yeah, Tetris. Didn't you notice? Maybe you guys ever noticed that every Tetris piece has 4 squares in it? Like I said that last year to my students, and like they were amazed. That, what? I'm like, really? So it's right in there. All right. Penta, guys, is 5. Hexa is 6. Hepta is 7. That's one that typically people will forget about. Octa, like an octagon, is 8. Nona is 9, and then Deca is 10. You've got to know these. All right, you've got to commit these to memory. All right, you've got to know what those prefixes are. So here's how we're going to talk about them and how they play a part in naming covalent compounds. So here we go, guys. The less electronegative atom is always first, and this is what I've talked about all along, even going back in the last unit. The element, guys, that is further to the left always comes first. The further to the left on your periodic table. The first prefix, the first element, guys, only gets a prefix if it has more than one atom present.
One is mono.
Right. But the first one will only get the term mono. So mono will only be used in the second element. It will never be used with the first one. That's what this is saying. So only gets a prefix if more than one element is present. And we're going to add that note in there, Briley. I'm glad you pointed that out. Mono is only used with the second element. And this is something, guys, that is super critical that you've got to remember. Mono, the prefix mono, is only used with the second element. If you have one of the first element, you just say the element's name. There is no prefix that goes with it. The second element always gets a prefix, and your ending is "-ide", just like we've done already. Ending is "-ide". All right? So the second element, guys, always gets a prefix, and your ending is always "-ide". Now, this last kind of bullet point right here, that I'm putting a red star next to, guys, if your prefix ends in O or A, we typically drop that vowel, we drop that letter when your element begins with a vowel. So, for example, it's monoxide or pentoxide. It's not monooxide or pentaoxide. Now, if you put that down, I'm not going to mark it wrong. Okay? I know we're learning about it. You'll get the feel and the gist of it, just like you did with the names with ides as we went through and did more practice, folks. But typically that's what happens. It's just kind of too long and too cumbersome. So we just kind of chop off that last vowel, or O or A, with the prefix if your element begins with the vowel already. So it's pentoxide, monoxide. It's still trioxide. It's just O or A gets dropped off. So this is pretty much it for our naming rules, guys, for covalent compounds. That right there. Prefixes. The prefixes tell you the subscripts. They correspond to the subscripts. I'm going to add that in there at the top. That's something that people tend to forget. All right, the prefixes tell you the number of atoms present. All right, so they correspond to the subscripts. All right, they correspond to your subscripts. So, when we're going from a formula to a name, we look at the subscripts to get your prefix. When you're going from a name to a formula, there's no crisscross method here with covalent. Crisscross is only for ionic compounds. Whatever the prefix is, that tells you your subscript right away. These tend to be much easier to name, guys, than ionic. Why do you think we spent a whole week with ionic? Because they are harder. They're much more difficult. There's a lot more rules to remember. As soon as I introduce this, everybody wants to start doing prefixes for every single example, right? That's why we're going to spend the next 2 days of just practicing mixed practice, ionic and covalent together, because you've got to be able to distinguish each from each, or each one from whatever one you got. All right, can I move on to the next slide? Anybody still writing? All right, here we go. We're going to practice. We're going to do the first couple together. Have you guys do some, and then I'm going to pass out a flow chart that's going to help you guys out, and then we'll talk about that, and then we'll have you guys have time for practice. All right, AS205, what's the first thing? Oh, you weren't done? So we're going to practice, okay? First things first, what do you have to do? Is it covalent or ionic, guys?
That's definitely...
How do we know it's covalent? Two nonmetals, guys. So, as soon as you see that it is covalent, that means we're going to use what to name? Prefixes, guys. Once you identify it's covalent, you will use prefixes. So, all right, 2. What's our prefix for 2? Di. So this is di. As is what element? Arsenic. This is diarsenic. And then 5 is what prefix?
Penta.
All right, so it's penta. But O is what element? Oxygen. So we're going to drop the A from the penta. So it's just going to be pentoxide. And our ending is IDE, guys, every time. Every time. We won't have, in this class, we won't have covalent compounds, that contain polyatomics. Okay, so don't worry about that. Polyatomics, guys, will only be with ionic compounds. All right, diarsenic pentoxide. The next one, is it covalent or ionic?
Covalent.
Covalent. Why? Because it's two nonmetals. So how are we going to name the first one, guys? Sulfur, right? Because will we use mono with the first element? Guys, mono. The prefix mono is only with the second element. So this is just going to be sulfur. 6 is what prefix? Hexa. And then what are we going to finish it with? Fluoride. Sulfur hexafluoride. Anybody remember we saw a video with sulfur hexafluoride in it? No?
Wait, you didn't show us that full video of the chemist dude?
Ah, that's what I was just referring to. I want you guys to do the last 3 here. So those are your answers here for those. The biggest thing, the biggest mistake that my students make, and I've seen this year after year after year, is the biggest mistake is they put mono with the first element, guys. The first element will never have mono. Mono prefix is only with the second element. If you have anything else besides mono, or besides 1, you will have a prefix. All right, but mono will only be used with the second element, not with the first. The other mistake I see is when everything gets mixed together, people start putting prefixes for everything. And that's what we're going to practice with. This next thing we're about to do, guys, that flow chart that I passed out, that's what you need right now. Oh, I'm sorry. Acids. Before we get to the flow chart, we're going to talk about acids. All right, so in your notes, naming acids. Good rule of thumb, guys, for this class. If the formula begins with H, it usually is an acid, except for water.
What?
Water special, and I'm 70% water, so I'm 70% special.
When we're talking about acids, guys, the whole point, if you look at most of these, all right, most of them are polyatomic ions you would have memorized. And then what makes them an acid and not a polyatomic ion is 1, do they have a charge anymore? No, because they've been balanced out by hydrogens. So acids, guys, have hydrogens that come in to balance out their charges. Right? So like H3PO4, that's phosphoric acid. Well, what's the polyatomic ion that we have there? PO4, which is phosphate. Phosphate, guys, is a 3- charge. So therefore, hydrogen is a 1+. I have 3 of those to balance it out. That's basically what's happening at the most simplest definition, guys, of acids. We have a whole unit on acids and bases later in the year. Okay? So we will analyze those in depth, but for now, that's kind of what you're doing. So when in doubt on your quiz on Friday, if you have to go from a formula to a name, guys, or a name to a formula, look for those polyatomic ions. This is why it's so important that you memorize those polyatomics that I gave you, because these are acids that we're going to see. They're common, weak, and strong acids that we will see all year long. It's pretty much polyatomics and kind of you change their names a little bit, and we're going to learn that here in just a minute. All right? Now, guys, we're keeping it very, very simple right now with acids. There's a whole naming system just for acids. We're going to talk about it in our flow chart here in just a second. You don't have to know that for this class. AP, you guys will go on and learn it, all right, in detail. For now, we're going to keep it as simple as possible. These are the acids you need to know. So get your flow chart out. This is what you guys are going to want to look at tomorrow, and not for necessarily for your homework tonight, but tomorrow in class when we do practice, this is going to be your number one resource. All right? This is the process that you need to go through to help you name compounds. So you want 3 different colors, guys, and if you can, 3 different color highlighters. It's going to make it easier for you. So here we go. There's 3 questions you're going to ask yourself. The first one, this is when you have any compound, guys. So when everything's mixed together. Up to this point, we've isolated ionic by themselves, and we talked about molecular just now in class. And then acids, well, after this point, they're all going to be mixed together. So these are the questions you got to kind of go through in your mind to help you out. So the first question is, does it start with H? Does it start with H? All right, that's the first question. If the answer to that is yes, you're going to ask yourself, is it binary, meaning 2 elements? If the answer to that question, guys, is yes, you're going to name it like an ionic compound. Then you're going to use the term hydro, and you're going to call it ic acid. So, for example, if I had something like HCl, does it start with an H? Yes. Is it binary, meaning only 2 elements? Yes. We're going to name it like an ionic compound. So I would name this hydrogen chloride, because it's an ion. I would name it like an ionic compound, hydrogen chloride. But what I'm going to do now, to make it the acid name, I'm going to call it hydrochloric acid. Hydrochloric acid is what I would do here. All right. So this is kind of going through the naming, how we actually name acids, folks, for your quiz and your test. Memorize the ones that I told you to memorize. All right. Those of you taking AP, this is how you will name compounds next year in AP. All right. But for this class, we're going to keep it simple. Know those 7 common ones and strong and weak ones. Going back to your second question there, is it binary? If the answer to that was no, then it's a little bit different of how we name. We're still going to name it like an ionic compound, but we're going to drop the hydrogen. If there's a hydrogen there, well, there's going to be a hydrogen. We're not going to use that in the name. 8 becomes ic, ite becomes us. So an example of this would be something like, let me get my pen. Something like HNO3. Does it start with an H? Yes. Is it binary? No. Right? This is what type of compound, guys? It's not binary, it's ternary. All right, ternary. So what we're going to do is we're going to drop, if we were to name this, guys, like an ionic compound, how would we name this? Hydrogen nitrate is how we would name it if it was an ionic compound. We're going to drop the term hydrogen. So now we just have nitrate. Okay? 8 becomes what? I see. So, guys, this is going to be called what? Nitric acid. Nitric acid is what this would be called. That's it, guys. So when you have an acid, what do you have in every name of an acid? Acid, right? It's that simple, guys. That term acid is going to be in every single name when you're naming an acid. All right? Again, this is more complex, guys. Know your 6 acids that you need to know. Okay? I'm going to erase my examples. Is that okay? The blue? Everybody good with that? All right. Going back to our original question that we had, does it start with an H? So up until this point, everything we talked about did start with an H. If it doesn't, we're going to move on to the next piece. So you want a different color highlighter here. So if it doesn't start with an H, the next question you want to ask yourself, guys, basically, if it doesn't start with an H, then we're identifying as an ionic or covalent compound. So that's what you're trying to distinguish. Does it have a metal and a nonmetal? If the answer to that is no, that means it's a molecular compound. And actually, I'm going to... So if it's molecular, what does molecular mean again? Covalent. Add that in there. All right. If it's molecular, guys, we use our prefixes. We're going to make a side note over here. Only covalent / molecular compounds have prefixes. I cannot stress that enough. Only covalent / molecular compounds have prefixes. So if it's covalent, our work is pretty simple. Notice, what are we saving for the end? What type? Ionic, guys, because those have a lot more rules. So this bottom part of the chart, guys, is summarizing our ionic rules. So if the answer to that was yes, if the answer to that question, does it have a metal and nonmetal, guys, is yes, that means it must be ionic. Then we've got to go through our ionic naming rules. So first things first. Is the cation in group 1, 2, or is it aluminum, zinc, silver? What are other elements we were going to add there? Really, guys, what is this question asking us? Is it type? No, is this type 1? All right, is your metal, your cation, is it type 1? What are the other 2 elements we need to add to this for type 1? Gallium and cadmium, Cd. All right, because that's part of our mini staircase. You've got to know those. All right, if the answer is no, thank you. You're going to want one of these, Jenny. If the answer is no, it's the cation plus the anion name. We must calculate the charge because we have a type 2. So down here, guys, these are type 2. And this is type 1 over here. All right, if it's type 1, it's just the cation plus the anion name. What do we do with all anion names with ionic compounds? Ide. They become IDE. So the anion name, guys, is just ide at the end. Unless it's a polyatomic. If you have a polyatomic, you just leave the polyatomic name as is. If it's type 2, you've got to calculate it. So, guys, if you forget how to do that, you can look back in your notes, or you can go back and watch my videos from those days where we did that. Go back and relearn how to do that. Guys, I'm telling you, this chart is going to be super, super helpful. If you lose this, I'm going to post this file on my website. All right, underneath Unit 5, it'll be called Naming Compounds Flowchart. All right, But this is going to take you through this. So tomorrow, as we are practicing, this is going to be your number one resource to kind of walk you through how to identify and name it correctly. Any questions?